Welcome to day 14 of my Oracle DBA 100-day challenge. Today we're stepping into one of the true foundations of Oracle performance tuning, server parameters. If networking controls how users connect, server parameters control how the database behaves internally. These parameters define how Oracle allocates memory, manages processes, handles SQL optimization, logs recovery information, and controls many core behaviors of the instance. In short, server parameters shape performance. What are server parameters? Oracle uses initialization parameters, stored in either an SPFILE or a file, to configure the database instance at startup. These parameters influence memory distribution between the SGA and PGA. They affect SQL optimizer decisions. They control crash recovery speed. They determine how many users and processes the system can handle. They influence parallel execution behavior. And they even control file placement and logging. Every serious DBA must understand how these settings impact real workloads. Key categories of tuning parameters. Let's break them into practical groups. Memory parameters. Memory tuning is often the first place we look. Parameters like memory_target and memory_max_target enable automatic memory management, allowing Oracle to balance SGA and PGA automatically. If you're using automatic shared memory management, you configure SGA_target and SGA_max_size. For PGA, PGA_aggregate_target controls total memory available for sorting, hashing, and work areas. Work area_size_policy should typically be set to auto for modern workloads. A properly tuned memory environment prevents excessive swapping, reduces temporary spills, and improves query response time. Poor memory settings can silently damage performance. Process and session parameters. These define how many connections your system can support. The processes parameter sets the maximum number of operating system processes that can connect to Oracle. Sessions defines how many active sessions are allowed and is derived from processes. Open_cursors controls how many cursors a single session can keep open. In application-heavy systems, especially with middleware, microservices, or connection pools, these parameters become critical. Set them too low and users get errors. Set them too high and you waste resources. Balance is essential. Optimizer parameters. The optimizer determines how SQL statements are executed. Optimizer_mode can be set to ALL_rows for throughput or first_rows_ for response time optimization. Cursor_sharing controls how Oracle handles similar SQL statements. Force can reduce hard parsing but must be used carefully. Optimizer_features_enable lets you lock behavior to a specific Oracle version, which is useful during upgrades. Statistics_level controls how much performance data Oracle collects. Correct optimizer settings reduce hard parsers, stabilize execution plans, and improve overall SQL performance. Logging and recovery parameters. These parameters influence redo generation and crash recovery behavior. Log_buffer affects redo buffering. Fast_start_target controls how quickly Oracle recovers after a crash. Archive_log_target determines archive frequency. DB_recovery_file_dest and its size configure the fast recovery area. Improper configuration here can cause slow recovery or even database hangs if the recovery area becomes full. A DBA must always monitor recovery-related parameters carefully. Parallelism parameters. Parallel execution can dramatically improve performance in data warehouse and batch systems. Parallel_max_servers limits total parallel processes. Parallel_degree_policy controls automatic parallel behavior. In RAC environments, parallel_force_local can restrict parallel execution to a local instance. However, poor parallel settings can overload CPUs and hurt performance instead of improving it. Parallelism must be controlled, not simply enabled. How a DBA tunes parameters. Parameter tuning is not random adjustment. It follows a structured approach. First, understand the workload, whether it is OLTP, data warehouse, or mixed. Second, review performance using AWR reports, ASH data, and dynamic performance views. Third, apply small and measured changes. Fourth, document every modification. And finally, always use SPFILE for persistent changes instead of FILE. Never tune blindly. Always measure first. Useful commands. You can check current settings using show parameter memory, show parameter processes, and modify values carefully with alter-system set PGA _aggregate _target equals 4G scope equals both, or for parameters requiring restart. Alter-system set processes equals 2000 scope equals SPFILE. Always understand the impact before applying changes. Today's key message. Server parameter tuning is not about guesswork. It is about understanding workload behavior, monitoring the system, and applying controlled, evidence-based changes. When tuned properly, parameters unlock stability, scalability, and performance. When misconfigured, they create silent bottlenecks. That completes day 14 of my Oracle DBA 100-day challenge. I'll see you in the next lesson.